Hi everyone. So today we are going to talk about the future of digital health, and that is AI-driven nutrition assistant. We are going to see in this video how that is helpful in our day-to-day life, how that is going to bring efficiency while logging our meal. So my name is Surjeet Singh, and I'll be there guiding you through the complete video. So let's begin. So starting with the problem statement only. While logging, like while tracking your nutrition, you might have seen there are multiple different applications available, and while those applications have lot of challenges, and due to those challenges there is a lot of abandonment rate in the first week only. Like most of the users leave the application in the first week only. So why is that the case? I think that is majorly the biggest issue with those applications could be they are very tedious. Nobody wants to log the applications which log the meals in the applications where they have to go through the complete database, and they need to find the meals and the portions, and then which obviously takes a lot of time and effort, and then they will be able to log it. So what could be the solution? So actually what they want is a very simple, a very intuitive, a coach or a friend which should log the meal from their end. So it should not be very complicated to them. It should be very simple and not very time consuming. It should be very intuitive. So what we can do, how will it help? So the solution that comes to rescue this situation is, what if we can just talk to a nutrition app? Like we can snap a picture and boom, your calories are logged, and the portions AI estimated itself, and all the protein, all the carbs, everything is logged completely. Just taking a picture or just telling it via the voice, or if you want any analysis, you can simply ask or you can type it, and it will magically provide you all the answers without any effort. And all these things are very intuitive, like we talk to a normal human being. And what so coming on to the final solution that we provide is AI powered nutrition assistant. So what it provides is a complete a natural language conversation where we can have multiple input types of, like we talk to a human, we can simply text it, we can click a image, click a photo and send to the AI, and it will automatically analyze what all the food items are, and it will log from our side. And it will also track the like and give the nutritional analysis in the real time, and will keep your contextual, like it will be aware of your context, like it is very much personalized, uh, in contrast to the applications that are currently present in the market. Like the traditional approach is like, you open the app, you search for something. Suppose we are logging for scrambled eggs, we search for the scrambled eggs, and then we also then again search for another thing that is available in the meals. And obviously there are four five food items that are available in the single meal. Searching for them manually and then logging their portion size is very tedious. And what our AI assistant do is simply you take a photo, it will automatically guess the it will very accurately guess the portion size and the food items, and it will also search our database from its side and log the particular amount of calories or protein, and it can also tell you how much goal you have achieved within a timeline. So let's begin with the technicalities. And so the technical foundation could be, we can start with simply LLM. Like we need a LLM as its core. So LLM is a thinking core which have multiple tasks in our system. So it basically will decide all the tools and all, which I'll go on to that further in the video. But LLM decides what all tools to call, what all personalized recommendation that should be there, and everything. Like it also maintains the contextual awareness of the user. So it is a big brain of the application. And second thing is the tool system. So we have a very specialized tool, like for different tasks, and I'll come on to that later. And again we have the context manager and multimodal processor. So the multimodal processor is very important because it handles very efficiently all the type of inputs, which makes the app very much intuitive. like user can easily log through all the different modalities. Now coming on to the technical part. So here you can see like we are setting up the LLM itself. So as I told, the first part is to set the LLM so that it can understand the natural language and handle multiple input types and all, and also it can like scale for thousands of concurrent users. So here we are using the generative AI class provided by the Google only, and we are setting up some parameters, and you can see here, and we are also setting the model. We can define any model that should be able to call the tools or functions, and we can use that model only. And here you can see we have multiple different tools. So here is the tool definition, like tool names that I've provided, but actually they are the tool definitions, which I'll go through in the further slides. Yep. So here are the core tools that actually power the AI, that makes the AI intelligent, that gives the power to the AI to work on the specific task. So we have the like 4 5 different tools, that is nutrition logging, and to get the meal history, to like all the applications, but all the tools. But yeah, what suppose a nutrition logging will log all the new food entries, and meal history tool will access to the previous meals that has been already logged, and it will give you insight on that. Trend analysis will basically give you the trend of how much protein intake or carbs intake has been done, and what the trend looks like, how is it going. Health info is a very special tool because it is not simply a function, it is a rag inside a tool. So we'll go on to that in the further video, but giving you a overall idea is that it performs a rag. It will, instead of giving the power to, like, we are not giving the power to LLM to give health recommendations, because those are very specific and those are very risky to give LLM such power. So instead what we have done is we have provided the RAG capability, that LLM can simply search call for this tool, and this tool will internally use the RAG, and it will give the recommended documents to the LLM, and then LLM will process those documents and give you a natural language response. The last one is the meal updates, and it is a very helpful tool, I would say. What it does is, suppose you logged a meal and accidentally you logged multiple items, but you don't want to do that. You wanted some additions or some deletions or some updations in those food items. You can simply say that I want to edit that thing, and I want such thing to be happen, and this meal update will update that particular meal, and yep, you are set to go. So now coming on to the tool by tool processes, like how every tool is defined. I'll give you a basic general overall idea that will help you to develop your own tools. And so you can see here, like here is the nutrition logging tool, which actually this is the actual type that Gemini and Google recommends to give AI, to feed AI so that they can easily call the tools. So first one is the name, and second is the description. Name is simply the name, and description, description, like having a very intuitive, very clear description is very important in case of tools, so that AI will not hallucinate, and it will call it will accurately call all the different tools. It will make a very decisive manner. So third would be the parameters, where we will have all the different parameters like time of meal, food items, and all the what could be the parameters and all. So this way we can define the tools. So what this tool do is, it basically understands the natural language conversation, and will have a natural language conversation, and it will internally like AI will call this tool, and it will seed the food items and how much nutrition it has, and this will internally log the food item in the database. Yep. So coming on to the process, how it processes. So suppose there is a image, we're logging the nutrition via the image instead of the text. So we take a image, like we take a photo of food item, and we send it to the processor. It will process the image, and it will get all the, you can see here, it will get all the nutrition and all the food items portion all through the image, and it will then convert those food items in the normal text. Suppose when we are logging to the text, we say I have eaten four eggs in the breakfast. But when you take image, you don't say such things. You just take the image and you send it to the AI. AI will automatically internally convert it into the normal text that you have eaten four scrambled eggs. Now I want to log it. So this happens internally, and now the food items have been extracted, and the nutrition data we get through, and that is using the calculate nutrition tool. Like this is an internal function. So this we can do internally, and then it logs the nutrition, and this is how the process gets completed. Yeah. So next would be how we analyze the meals, analyze the tools, analyze the trends. Sorry, analyze the trends. So it is you can see here again we have the same structure of the tool, and here we have an analyzer that will basically generate the trends. So in trends what we have did is we can user in the trends question could be like user asks how is my protein intake going for this week, how am I doing in the terms of calories and calories intake. So all these trends actually go through this analyze trend or analyze meal tool, and this tool internally calculates all the maximum and minimum values daily about daily, weekly, and monthly basis. Then here you can say see we can get the nutrition history. First we get the history, and then we calculate for the complete suppose the input type was the weekly. So we calculate the maximum and minimum intake of particular macro that user has asked for, and then we supply it to the AI. Now AI will generate uh, a proper natural language answer. Instead of telling the user like dumping complete data, we will generate a complete natural response, complete natural language response, and so that user will understand it very effectively. So like that you can see here the AI will say like your protein intake is average 95% of this week, and it will also say like it will also boost your confidence. And you when you are low on iron, so it will also tell for these days you were low on iron and your meals were inconsistent, like consistent or inconsistent, so all those things. So now we also have issue of context awareness. So the AI should be very aware of the user context in terms of health. We can't let AI to think that user has such issues, or user don't have any issues. So like we have provided the complete user context. Suppose the dietary preferences of a user. AI obviously can't recommend non-vegetarian food items to a person who is vegetarian. So we need to tell all the preferences that he wants in the food item, and also what his health goals are. Someone wants to lose fat, someone want to gain muscles, so all those things. And also his daily targets for his target are, because everyone have different targets. Someone is very aggressive on uh, bodybuilding, or someone is very aggressive on losing fat, but someone could be very moderately involved in exercising or food intake or any such things. So these things are also very useful while creating the personalized recommendations. So here you can see it remembers the food recommendations and adapts to like nutritional targets that a user have. So now processing the user request is also like kind of a option, like kind of thing that we need to do very efficiently. So you can see first we what we do is we calculate the intent, what the intent of a user is. So we get to know what user actually wants. Do he want to log the meal, or he want to log the he want to get a complete analysis of all the meals that he logged, or whatever intent could be. Then we will generate the personalized response. So like here user can say log my lunch, and we know that we need to log the nutrition logging tool, and user can say how am I doing, so the trend analysis should fire up. And all these things are controlled by the AI itself. Now coming on to the multimodal processing. So as I told earlier that the complete audio and the images will be internally converted to the normal text form. So here you can see the same. Here we have a process text message that will process, like that will calculate the nutrition of the text, like the text that we have provided, it will calculate the nutrition of those food item after extracting the food item from the natural language. Here is the voice input. So here we first convert into the transcription, and then we use the same method to get all the nutrition related data. And same for the image input. First we get the portion size and get the complete food items, extract the food items out of the image, and then we use the same method to log and to get the, like, to process the text input. So yep, you can see the same thing here. Like, we are converting the image logging to normal text first, and then process it as text request for the LLM, because LLM uh, usually don't understand, like, the LLM that we were using is very efficient, and those efficient LLMs don't usually understand multimodalities. So if you want multimodalities directly, then we first need to have a LLM that is very capable of understanding the images. So instead, what we are doing, we are converting it into the normal text, and then we are sending it to the normal LLM, which will process it as a text request, and all the logic of handling the image and handling different files works internally only. Yeah, so we utilize the common meal logging method only. Yep. So here is the smart history access. So what we are doing is, we this is the meal history tool. It is the same. It is in the same format that I told earlier. We have a name, description, a very detailed description. It could be more detailed. It is just for example purposes, and we can have a different parameter setup. And then we can have get meal history method, where we will be getting the meal history of a user, and this tool will be called based on the params that we have. So in params we have reference date and what type of meal that user is referring to. It could be breakfast and lunch or dinner, or maybe all the meals. And the analysis could be of, like, daily pattern, weekly pattern, or a single meal that user have logged. So we can use this tool in the queries, like, what did I eat for lunch yesterday? Then AI will go through, like, call this tool and go through the history of user meal logging pattern, and it will calculate all the, suppose it is a weekly, this option, it is a daily, weekly pattern. So it will calculate how the intake has been through the week. And if it is a single meal query, it will tell that what you have taken in the single meal. Now, next would be the real-time modifications. So this is really a game changer that I said I'll go through. And so how it works is, I've defined the tool, and it takes simply user ID, and it takes a time of meal that we want to modify, and like all the food items, and should append or should log. So we can either append the food items that we want, or we can remove the food items if we want to. And here's the method that we have to define. We can define it ourselves, and we can define all the functionalities that we want into it. So the user flow could be like, suppose user said, I ate 4 breads and 5 eggs in the breakfast, and AI logs it using the logging meal tool of functions. And then after 2 minutes, user thought that he didn't have 4 eggs, instead he had 2 eggs only. So he would say, I didn't have 4 eggs in the morning, I only had 2 eggs, can you please update that? And then I will call this tool, and it will remove the 4 eggs and append the 2 eggs. So this is how it works. And we also have proper error handling, so that the AI never hallucinates, or if there is something breaking apart, we shouldn't show user the message that this particular thing has been broken. We should let them retry after some time, and all those things. And it also have internal retry mechanism. Suppose something works for some, like, millisecond, and we can retry it again, then, and if it works, and we have implemented the retry mechanism also. Coming on to the privacy and data security, we completely have encrypted the user identities, and all the things are GDPR compliant. And we are having the nutrition data only. We don't have a proper health data. We don't store the proper health data, and user have the ability to delete all the data that it has, like, user has logged and user has stored in this application. And we also share the policy, like, we don't have to share the data to the third parties. Now, since that was a complete AI flow, how we will be developing agentic flow kind of thing for nutrition assistant. But to access it efficiently, we also have to create the API, and this API could also be well thought of. That we can either create a simple API that will process everything internally, and it will give a response at the end when and at the end when it processed everything. But the better approach could be we can implement a streaming API which will keep the client know, like client in loop, that all these things have been completed, and all like what the current process that has been happening in the background, what the things have been failed, and all the messages will be delivered in the real time. So the streaming API will work very good in this case because we have multiple tools. We will let the client know that all these tools are being called right now, and if there's any tool failed, will the client will also get to know what exact thing has been failed instead of getting a final failed message, which doesn't signify a lot of things. Yep. So that thing is where like we can set the AI thinking and we can get a complete thing in the real time. And it seems like a natural language that user is also very much involved in these things, that he gets to know that what exactly is working. So, what is the impact of this nutrition assistant? So, it actually gives really good results. That it the time efficiency is reduced from like logging meals from 5 minutes to I guess 30-40 seconds, and the it is like you when the user is able to log meals that fast, he usually tracks the nutrition, and since the nutrition is well tracked, then the goal achievement is also faster. Also it increases the user retention, that user doesn't leave the application just after within a week after getting tired of searching through the databases and logging the meals manually. Yep. So we also have an architecture diagram that I can show you, and that would be helpful. Yep. So here it is. So, so this architecture diagram is the complete flow that you can incorporate while building this assistant. And so it starts with the user interface, and user have multiple different input types. That is image input, voice input of the text, or the text input. So text input is the simpler one. It will directly go to the agent, and while the voice input will using the speech to text, and for image input will use a image recognition model. So this image recognition model is tuned so that it gets very accurate data of the food items, and also accurately defines how much portion it is. So it recognizes all the food items and then converts it into the text like here we have, and then send it to the agent. And so when agents receive the complete text, it have three of the task. Either it can log it will have the logging task, or it will have the listing task, or it will have a health related Q&A. So we also have a tool for health related queries, because we can't directly let AI to give health recommendations. Instead, we are incorporating a RAG. You can see here. Yeah. So we are incorporating a RAG that will give the health. You take the health related queries. It will use a complete flow of like whatever RAG application you can use here. We have used the GCP Vertex AI vector search, but you can use anything that provides the RAG capability, and then you will get the relevant medical docs, and you will feed that back to the LLM. And here is the LLM that we have used. So we have used a Gemini, and we give it the text input with the function context that the function has been called, or the what has been the response of a function, and it responses back in the text format, and that text format is then supplied back. Uh, that text format is then supplied back to the user in the streaming format. So you can see that here also. Now coming on to the different methods that we have a logging task, we have uh, listing task, and we are clear about the health related queries. Health related queries could be like what is the minimum potassium intake for a user or around age 15, or something like I'm 25 years old, what will be the average protein intake, and my weight is 70 kgs. So kind of that. And that all the queries goes through the RAG, and in RAG we have already seeded medically verified documents, and those help in searching and getting the proper result. So in the functions only, in the functions we have a create new meal, we have a copy existing meal. We can also copy the existing meal by saying I have eaten the same thing which I have eaten yesterday's night. So isn't it very helpful that we don't have to go through the same thing and repeatedly log the same things which we have done already. Yep. So we also, like, all the things are like going through the nutrition API to get the nutrition values of the food items. And after we have after we have got the nutrition values, we simply use a DB layer to log everything into the database. So it is a simple flow of the data that will be there. Yep. So that was all about the nutrition assistant and how its functioning would be. And I hope you got a better understanding. And if there's anything else, please do comment in the video and let me know. I'll surely respond to the queries that you have. Thank you. Thanks a lot.